Hi, scholars. Happy Thursday. Today is April 2nd, and I'm so excited for us to dive into our next math lesson. I do want to start, as always, with some shout outs for our 100% club. Really exciting. Our list is getting longer. So these are shout outs for scholars who got a 100% on yesterday's assignment. Representing from UNC, we have Emmanuel, Anaya, Miguel Angel, Dillery, and Annalie. Some familiar names up there, some scholars who are getting hundreds over and over and over again, and some new members as well. From SCU, a list almost as long, we have Danya, Nevea, Jakira, and Alejandro. Really nice work, SCU. Duke, again, you only have one 100% representing. Duke, I did notice that yesterday you had scholars who were turning in work late, who were scoring 100%. But you got to turn your work in on time if you want to be in the shout out club. So huge shout out to our one Duke scholar. Excited to see all of these lists a little bit longer after today's lesson, meaning we not only crushed our work, but we turned our work in on time. A quick reminder that when you are done taking your independent practice, this is of course after you watch the video, you do need to click on the button that says mark as done. Right now we have about half of us doing this and about half of us are doing the work. We're submitting our Google form quiz, but we're not clicking this button. So starting tomorrow, I'm not going to grade your work until you have clicked the mark as done. If you have any trouble finding it, please shoot me a message and I can help you out. But you do need to click on this button that says mark as done. All of your grades for lessons 1, 2, and 3 all of your assignments have now been graded and posted. As a reminder, you can check your grades by clicking on classwork, clicking on the assignment either from Monday, Tuesday, or Wednesday. When you click view assignment, it will pull up your grade and some feedback as well. Huge shout out to both Kamaya and Jaden, who have done such a great job responding to their feedback. Remember, after you read your feedback, you can just respond with a quick got it, or some of you were even saying things like thanks if I'd noticed that you've done a really great job. All 4 of your assignments must be completed. That's Mondays, Tuesdays, Wednesdays, and then today's before you take tomorrow's quiz. So at the end of this lesson, I will tell you a little bit more about the quiz we're taking tomorrow. Tomorrow there will be no new video, just a quiz, but it will not be open to you until you've completed Monday, Tuesday, Wednesday, and Thursday. You will be getting a message from me later today if you're missing any assignments. Finally, huge shout out to all the scholars who I can tell watched yesterday's video really carefully. You guys knew exactly what color Watson's fur was, as well as being able to, of course, more importantly, do the math. One final piece of advice about your online assignments. This sounds a little strange, but I don't want you to write incomplete sentences. I know it's so different from what Miss Trotter and Miss Richardson are telling you, but think about it just like when you take a quiz on Illuminate, you don't usually write out your answer in a complete sentence. The reason for that is just the computer is scoring it. I always go back and look. Thinking, wait a second, I got that right. The computer may just be counting it wrong if you write it in a complete sentence. So even if the question asks, how much did all the hot dogs cost? Don't write the hot dogs cost $10.50. Just type in $10.50, just like you would in Illuminate. I'll continue to give you reminders, and I'm always happy to go back and change your grades, but it will just make your grades a little bit easier for you to see as well. All right. I'm really excited to dive into today's lesson. Today, we are only focusing on the standard algorithm. We have noticed that this is probably the most efficient way of solving decimal problems where we need to multiply a decimal by a decimal. So I'm really excited for us to practice, make sure we know exactly where to put those decimal points, and then ace today's work. Let's take a look at our first problem. Do make sure you have your paper and your pencil ready to go so you're solving along with me. All right. Our first problem today, we actually see Grace's work. So Grace is a scholar. She doesn't go to Vista College Prep. She does not know where to put the decimal point when she multiplies. So she was trying to multiply 37 and 24 hundredths times 5 and 3 tenths. She's pretty good at the standard algorithm. So she actually solved correctly using the standard algorithm. All of her digits are correct. But she got this answer that you see at the bottom of 1,973,720. And Grace is thinking, ay, that just doesn't seem quite right. I need to figure out where my decimal point goes. But she doesn't know where it goes. So we're going to help her out. The first thing that we are going to do is we are going to estimate. I've been saying this all week. The reason that we estimate first is it helps us figure out about where the decimal point should go. We're going to estimate today by just dropping the decimals off, basically turning our number into a whole number. So you can think of turning your 37 and 24 hundredths. I'm just going to chop off the decimal and make it 37. My 5 and 30 hundredths or 3 tenths, I'm just going to chop off the decimal and make it 5. And by figuring out 37 times 5, I can figure out about how big her answer is. You may have another strategy that helps you find where the decimal is. Because the math has already been done for you, we're going to start with just 2 minutes. This morning, I want you to figure out where does her decimal need to go. You can still set up your scrap paper by copying down the problem so you can see exactly what it is she's multiplying. Just like this, I'm going to leave the her work up so you can see her digits, and your job is just to figure out where does her decimal go. Take 2 minutes. Go ahead and get to work. All right, we're down to about 15 seconds. Finish it up. Make sure you've clearly placed your decimal point and you have your estimate so you can make sure it's in the right place. All right. Let's check in and see what some scholars did to solve this problem. So we were looking at 37 and 24 hundredths times 5 and 3 tenths, or 30 hundredths. The first thing I want to do is actually estimate what this is going to be. And so the first thing I want to do is just drop my decimal points so I can just multiply with whole numbers. So I'm going to estimate by thinking of this as, let's see, 37 and 24 hundredths. I can just take off my 24 hundredths. This is about 37. And 5 and 30 tenths, well, that's just about 5. So I can solve for 37 times 5. This is going to give me about how much my product will end up being. It's not going to be exact, but it gives me a good idea of where the decimal point should go. Now, a couple different ways I can solve this. I could just solve it using the standard algorithm. I could use partial products. I know that 30 times 5 is going to be 150. And then 7 times 5 is going to be 35. So 37 times 5 is going to be 185. Make sure that you have an estimate, a careful estimate written on your paper. So I'm looking for an answer that's around 185, which I notice has 1, 2, 3 digits. It has a hundreds, a tens, and a ones. So I'm going to be looking for an answer that probably also has about 3 digits, a hundreds, a tens, and a ones. Her original answer of 1,973,720 is just too big. That has 1, 2, 3, 4, 5, 6, 7 digits. It has a thousands place and a tens thousands place and a hundred thousands place and a millions place. That's way too big for about what 37 times 5 would be. And so as I think about this answer, I know I'm looking for an answer that has a hundreds place, a tens place, and a ones place, or 3 digits before the decimal point. And I know I can go back and count the number of decimals that I had. In her work right here, there was 1, 2, 3, 4 digits after the decimal point, which means I'm going to need to move my decimal point 4 times. So by using both my estimate that it's going to be around 185 with 3 digits before the decimal point and 4 digits after the decimal point, let's see if I can figure out where this decimal point should go. I know she got to an answer of 1,793,720. I'm looking for about 3 digits before the decimal point with a hundreds place, but nothing bigger. So I need 1, 2, 3 digits before the decimal point. And I also see that she's going to have 1, 2, 3, 4 digits after the decimal point. 1, 2, 3, 4. And so if I put my decimal point right here for an answer of 197 and 320 thousandths, this is very close to 185. They both have the same number of digits. Before the decimal point. They both have those 3 digits. They both have a hundreds, a tens, and a ones, but nothing more. I also could double check by noticing that there are 1, 2, 3, 4 digits after the decimal point. And so I need 1, 2, 3, 4 digits after the decimal point. So 2 ways for me to check where my decimal point goes. If you put your decimal point in between the 7 and 3 for an answer of 197 and 320 thousandths, nice work. Go ahead and give yourself a beautiful star on your paper. Nice job. So as we're multiplying today, we are going to push ourselves to all use the standard algorithm because it's just the most efficient way. Plus, we already know how to multiply using the standard algorithm. The trick today is figuring out where does that decimal point go. We can do this in two ways. First, by estimating, by dropping the decimal to just turn this into a whole number, so I can multiply something such as 37 times 5. I can also count the number of digits after my decimal point. This is going to tell me how many times I need to move that decimal point. Let's practice a few more. All right, so this one does have some multiple choice. However, the directions want us to find the product first using the standard algorithm, and then we can use estimation to choose the correct answer. Now, as I take a look at these answer choices, I know that once I've estimated, I can probably figure out which is the correct choice. That's a great strategy. We're also going to practice actually solving it using the standard algorithm. So let's take a look. I have 18 and 42 hundredths times 3 and 54 hundredths. First thing I need to do is I need to estimate. Find some room on your paper. Let's go ahead and just copy the problem down. All right. Now that we have it copied down, now we're ready for our first step, which is to estimate. In order to estimate, I'm just going to turn my decimals into whole numbers. All I need to do is just drop the decimal. So my 18 and 42 hundredths just becomes, that's right, 18. And my 3 and 54 hundredths just becomes, you're right, 3. Let's go ahead and solve this. You can use standard algorithm, you can use partial products, however you like to do 18 times 3, and go ahead and write the answer on your paper so you have your estimate. All right, I got an estimate of 54. I see that everybody else also got that same estimate of 54. So if we think about our estimate of 54, it's not going to be exactly 54 because we took off these decimals. But it should have 2 digits before the decimal point. It should have a tens place, and my answer should have a ones place. This is going to be really helpful when trying to figure out which is my correct answer. In fact, I can go back and look at my choices now, and knowing that my estimate for 18 and 42 hundredths times 3 and 54 hundredths was 54 with 2 digits, one in the tens place and one in the ones place. Show me a thumbs up if you can actually figure out which one is the correct answer before we even solve. Pretty cool. Another thing I can look at is as I look at my decimals, I'm going to count the digits I have after the decimal point. I have 1, 2, 3, 4 digits after the decimal point. So that means I'm going to need 4 digits after the decimal point. So going back and looking at my choices again, see if you can figure out which one is going to be the correct answer. I know that I need a tens place and a ones place, but nothing more. And I need 4 digits after the decimal point. If you think you can figure out what the answer is before we even solve, I want you to write your guess on your paper. I'm going to write mine too. We are going to solve it today because I just love practicing the standard algorithm. But then we can go back and see, did our strategy actually work? All right, take one more second to write down what you think the answer might be. All right, now let's get to work solving using the standard algorithm. Let's make sure we're setting it up on our paper with our digits lined up. So we are multiplying 18 and 42 hundredths times 3 and 54 hundredths. If it helps me to think about it, I can think about how I'm temporarily taking out these decimals to multiply. And so it's going to look like I'm actually multiplying 1,842 times 354. If you like to leave your decimal point in and just kind of ignore it as you multiply, that's great. If the decimal point confuses you a little bit, take it out and you can rewrite it without that decimal. I just have to remember when I'm done that I had these 4 digits after the decimal point that I need to account for. All right, this is a big one. Let's go ahead and get to work with our standard algorithm. I want you to do just the first row yourself, multiplying 4 by your 1,842. And then check up here to make sure that what you have matches mine. All right, I got 7,368. Great, looks like that's what everybody else got as well. I'm now ready to multiply by my 50. Got to put in my placeholder. Go ahead and multiply by your 50, and then we'll check up here to make sure we're on the same page. All right. I got 92,100 for my next row. Perfect. Looks like everyone is right along with me. All right, last row. I'm multiplying by my 300. If I think about those 2 zeros in 300, I need not just 1, but 2 0 placeholders. Let's go ahead and add those in. And then go ahead and multiply your 300 by that 1,842, and then we'll check in to see what you got. All right. I did get 552,600. Excellent. Looks like we're right along with me. All right, now comes the fun part. Now I just get to add my 3 products together. All right, so we are looking at a product of 652,068. I did all my math correctly. I did all my multiplying correctly. But this, when I compare it to my estimate, it's nowhere near that close. How many digits were in my 54? That's right, there were 2. Just a tens place and a ones place. And this has way too many digits before the decimal points. I know that right now, it's like the decimal point is right there. So I need to figure out, where does my decimal point go? 2 different things I can think about. One is the fact that I need 2 digits, a tens and a ones, before my decimal point. And then I went back and I counted my 1, 2, 3, 4. I have 4 digits after my decimal point. See if you can figure out where that decimal point needs to go. All right, looking good. I know I need a tens place and a ones place, but nothing more. I just need those 2 digits on before my decimal point. And I know I need 4 digits after my decimal point. Now, 65 is not the same as 54. I know those numbers aren't the same, but by estimating, I was figuring out about how many digits I would need in my whole number before the decimal, and 54 is pretty close to 65. 54 is not close to 652. It's not close to 6,520. It is not close to 65,206, and it is definitely not close to 652,068. All of those numbers would be way too big. And as I double check that I moved my decimal point 1, 2, 3, 4 times, 1, 2, 3, 4, looks pretty good. Let's go back since this one was multiple choice. Originally, we were able to make a prediction as to what the answer would be just based on our estimate. Was our prediction correct? It was. Nice work. Looks really good. All right. I'm ready for a couple more. Let's keep going. All right. We are ready for you to now try some on your own. You have 2 to try on your own. This first one does have a multiple choice option, and you will be able to figure out which one is the correct answer even before you multiply. You'll do this by estimating, by dropping the decimal to multiply by a whole number to figure out about about how much it's going to be. I just realized there's something a little bit tricky about this problem. Then you can count how many digits you need after your decimal point. You can make sure you have an answer that is pretty close, and then you can double check using the standard algorithm. Just one thing I do want to say, do be careful about this 6200ths. If I drop my decimal, I'm just multiplying by 0, and I know anything times 0 is just 0. That could be a little bit tricky. You might want to turn the 62 thousandths into 1 since it is closer to 1. All right. Best of luck. See if you can figure out about what your answer is going to be by estimating. That way you can figure out what you think the answer is going to be. I want you to write down that guess and then actually solve using the standard algorithm. I'm going to give you 4 minutes for the first problem, then we'll move on to the second. Go ahead and get to work. If you are done solving problem 1, you are welcome to move on to problem number 2. If you're not done solving problem number 1, that's okay. On problem number 2, it's not multiple choice, so you'll need to use the standard algorithm. I want you to start by estimating so you can figure out. I want you to start by estimating so you can figure out where that decimal point will need to go, and then solve using the standard algorithm. All right, let's check in just on problem 1. I don't expect you to have finished problem number 2, but I want to make sure we're on the right track with problem number 1. So let's take a look at problem number 1. First thing I did is I dropped my decimal point so I could make my estimate. I turned 11 4/10 into 11, and this one was a little bit tricky. I was a little bit weary of multiplying by 0 because 0 does just have such a strange rule where anything you multiply by 0 is 0. So I went ahead and rounded 62 hundredths to its nearest whole number, which was actually 1. When I multiplied that out, that gave me an answer of 11. So I knew I was looking for an answer around 11. I knew it would be a little bit less because I had to round this up to 1. I also counted my digits after the decimal point. I had 1, 2, 3 digits that fell after the decimal point. So I knew my answer should have those 3 digits after the decimal point and be pretty close to 11. Not 1, not 110, but pretty close to 11. So let's actually look at our multiple choice. Does anyone think they know what the answer is even before solving it? And this one is a little bit tricky. I can easily eliminate choice A. That's way too small. That's a teeny tiny decimal. It has too many digits. It has 1, 2, 3, 4, 5 after the decimal point. That's nowhere close to 11. I can also eliminate choice B. Again, it's way too small. Too many digits after that decimal point. But what about C versus D? We may have noticed that 11 has 2 digits. It has a 10, it has a digit in the tens place and a digit in the ones place. So is 70 68 hundredths my closest choice? It's not, because remember that when I estimated, I got to an answer of 11. Yes, 11 has 2 digits, but 11 is not that close to 70. 11 is actually much closer to 7, even though I know 7 only has 1 digit in the ones place. I also remembered that when I counted the digits after my decimal point, 1, 2, 3, I need an answer that also has 3 digits after the decimal point. So my correct answer is actually C, 7 68 thousandths. Then when I went to multiply it using the standard algorithm, I just took my 11 4/10 and 62 hundredths and I rewrote it as if there was no decimal. 114 times 62. After using the standard algorithm, I got to an answer of 7,068. I knew that was way too big. To figure out where to put that decimal, I reminded myself it needs to be pretty close to 11, and it needs to have 1, 2, 3 digits after the decimal point. So I moved my decimal point 1, 2, 3 times to get to an answer of 7 68 thousandths. If you got the answer of C, nice work. I want you to go ahead and give yourself a check. Really nice work if you were able to estimate that before even solving. We are not done with number 2. I do owe you a little bit more time. We'll take 2 more minutes. Go ahead and get back to work, both with your estimate and also solving the problem. 2 final minutes. Go ahead and get to work. All right, final 3 seconds. Okay, take like 10 more seconds to make sure that you've not only solved, but put your decimal point into the right place. All right, let's check in and see what we got. First thing I did was I estimated. I dropped my decimal, making 5 and 45 hundredths, just 5. Then I made my 2 and 75 hundredths, just turn that into 2. I multiplied 5 times 2 to get to an answer of 10. I was looking for an answer around 10. I set up my standard algorithm. I then took out the decimal point, and so I was multiplying 545 times 275. After all that multiplying, I got to an answer of 149,875. That's not too close to 10. That's way too big. So I need to put in my decimal. But where does it go? Well, I know I have 1, 2, 3, 4 digits after my decimal point. So my answer will need 4 digits after my decimal point. I also need something around 10. Can't put my decimal point right here. That's just 1. That's too small. If I put my decimal point right here for an answer of 14, that's close to 10, and that gives me 1, 2, 3, 4 digits after my decimal point. If I were to put it right here, that would be 149. That's too big, and I would only have 3 digits after my decimal point. So the correct place to put your decimal point is in between the 4 and the 9. We figured that out because we're looking for a number around 10 with something in the 10s, something in the 1s, and something that has 1, 2, 3, 4 digits after the decimal. If you correctly solved and got 14 before your decimal point, nice work. Please give yourself a big happy face. Nice work. All right, scholars, before I give you a few last directions about your independent practice day and your quiz, I do need to tell you a little bit more about Watson. So yesterday you met Watson and you knew that he had white fur. So today I want to tell you a little bit more about him. Watson, it's kind of funny because you think typically dogs like things like dog food or dog bones, but Watson's a very special puppy, and his favorite food is actually ice cream cake. He just loves ice cream cake. Doesn't matter the flavor, doesn't matter whether it's chocolate ice cream or chocolate cake or vanilla ice cream or vanilla cake. He does like sprinkles, but he just loves ice cream cake. If you're worried you might forget that, you might want to write that down, that his favorite food is ice cream cake. As a reminder, scholars, when you're completing your independent practice today, please don't write incomplete sentences. I know that sounds like the opposite of what we're always saying, but it's just so that the computer can actually score your work. I will go back in and correct any mistakes, but if I were to ask you, what is Watson's favorite food? You would just write in ice cream cake. That is his favorite food. He really loves ice cream cake. I also really love ice cream cake. So Watson and I enjoy sharing that together. Today, we worked on multiplying a decimal times a decimal, and today our focus was on the standard algorithm. As you're doing your work today, I really want to push you to try the standard algorithm. First, you estimate to figure out where your decimal will go, then you solve, then you place in your decimal. Mrs. Dunn and I noticed a lot of really strong multiplication on yesterday's assignment, but with some decimals in the wrong place. Please double check your work and make sure you're very confident before you submit it. Also, please remember that when you're done with your work, you do need to click Mark as Done so that we can grade it. Shout out to all the scholars who came to office hours today, to office hours yesterday. Kamaya put in a ton of work in office hours yesterday. So did Jasmine in office hours yesterday. Excited to see more scholars there if you have any questions. And shout out to scholars who came to reteach today to get some extra help as well. Tomorrow, I am looking for a few more scholars in that 100% club, especially from Duke. And then as a reminder, tomorrow there is no new video that you need to watch. You will just have a quiz you need to complete, but you cannot open the quiz until you've completed Mondays, Tuesdays, Wednesdays, and Thursdays assignment. The quiz won't even show up on your page. Once you have completed those, you'll just see the quiz pop up under your daily lessons where you usually find your work. I cannot wait to see how well you do on your quiz. All right, scholars, happy Thursday. I will see you tomorrow.